First of all, I'm going to review the terminology. Okay, suppose you have a number like a 1, 3, 4, 2, okay, 6, 5.1427, for example, right? How do we call it? We call it this one called the tens. Okay, this one then similar is called hundreds. Okay, and so on. But this is a decimal point, right? And this is called ones. This is called the tens. And this is called the hundreds. And so on. Okay. So those are the names. Okay, we needed to think of. Okay. And yeah, so ones, the ones digit, tens digit, and hundreds digit, right? And tens digit, tens digit. Okay, those are the terminology when we talk about. Okay. Now, and second point is, if we have like a 245, okay, this is a 245, right? So the hundredth digit is 2, tens digit is 5, and the ones digit is 10 digit 4, ones digit is 5. Now it's 200, so actually it's 200. When you read it, you have the sum of those three numbers. Okay, so hundredth digit. Really, if you change the hundredth digit, you change, not only just change one number, you change, hundreds, right? If from 2 to 3, then you increase the number by 100. Okay, so this is so we can decompose a 3-digit number in this form. Okay, so if the 2 digit change to hundredth digit change from 2 to 5, then you increase the number by 300. Okay, so similarly, like 421, right? This is gonna be 4. You can also write the 4 times 100 and the 2 times 10 and the plus 5. Okay. All right. Now, now let's take a look at the problems. The first problem. Okay. So in a summation, if the hundredth digit is changed from 8 to 6, I'm talking about one of the numbers. Okay. The 10th digit is changed from 1 to 4. So the result is 923. What is the original sum? Now you don't need to know which number you are changing, right? So you have several numbers. Okay, you have several numbers. So so this means at least one of the number has 3 digits. Okay, so the first digit, look at, right? So we have a look at this number, right? The 100th digit origin is 8, right? 10th digit origin is 1. We don't know the last digit, the units digit, right? So it's changed to 6, and this is a 4, and the stop. Okay, so the result is 923. So actually there's additional term here. This, otherwise you don't get 923, right? So it's a sum. So you have another number. Let's put it here as another number. Okay. So we want to see how do it change, right? Plus some number, another number. Okay. We don't need to know. Okay. So this change to 6 and the 4 and stop and plus. Okay. So the sum, then plus the number, unknown number. We really don't need to know. Okay. And the sum is going to be 923. We only needed to know is, the original number, how make the change from here to here, right? Right. So actually, from when you change 8 to 6, you actually decrease the number by right, by 200, right? But when you increase from 1 to 4, and you actually increase 30, increase the number 30. So the combined result is original number, right? Okay, and then decrease by 200 and increase by 30. So what is original number? Okay, now the original number could be more than 3 digits, right? Have 3 digits, no, it's possible, right? We don't need to know that. Okay, so you get this question mark, right? Is going to be 923. You know, you add the 200 and this is actually 9 minus 170, right? So actually they have to add 170. So total will be 3 and 9 and 1093. Yeah, there's oh, I made a mistake on this number. Okay, actually you cannot guess it. Yeah, the tens, it's not 8. Okay. Let me modify because this is another correct problem. Okay. I'm going to yeah, the original number is not going. There is no 8 there. Okay, otherwise. So this is a let's see. Yeah, let me pass this number. I'm going to carefully choose the next number. Okay. So the next number is yeah, it's not modified. So the next number is that next question is in a summation of several 3-digit numbers. If the 10th digit is changed from 2 to 5, okay? If the 10th digit changes from 2 to 5, and the 10th digit is changed from yes. Mm-hmm. Let's try to figure out that. So yeah, this original sum is if so it's changed from 2 to 5, if the 10th digit is changed to 5, several numbers, right? So we just need to focus on one of the numbers. So this number is 10th digit is 2, right? And the 100th digit is changed from the 100 digits origin to 1. So it's a 3-digit number, right? And plus some other numbers we don't need to know. Okay, so it's going to be okay. So it's a 5 as a 10th digit is changed to 5. The 100 digits changed to B. We don't know, right? Right? Yeah. So then add this number. Okay, this is going to be that's the change in the difference. Okay. So the difference here is look at right. So the sum. This is already the sum. 120. This cannot be 126 because the second, I'm going to change the problem a little bit. It's 200 because otherwise this problem is the problem here, right? This is cannot be 100, right? Because otherwise it's the sum of at least 2 3-digit numbers, right? So 1 plus 1 at least 2. Okay, then it's correct. Right? So it's 100 from 226 all the way change to 856. Okay, so the question is, what is how much is changed, right? Right. So clearly, when doing this process, right? What is increase? What is decrease? Right? I definitely have to increase the number, otherwise the sum is not going to increase. So from here to here, Okay, from here to here, the increased part, right? The increased part will be, you will have to figure out increased part, right? From 2 to 5, 10th digit, it increased 30, right? Right? You have to add a 30. So, but from 1 to B, and you will have to increase some number, how many hundreds, right? You have to figure it out, right? So how many hundreds you have to add, okay? In order to increase from, this is a total is some star 30, right? You have to add, maybe 400 or 600, right? In order to get 856, right? 6 is still 6, and the 2 to 5 is 3 already, right? So what you have to do is this star must be 6, right? This must be 6, okay? Only when it's 600 plus 30, when you add it to 226, you get 856, okay? So the B, right, should be 7. Why? Because it's changing from 1 to 7, then increase by 600, okay? So B should be equal to 7, okay? Only when you change from 1 to 7, you increase 600. Okay, the increased part, 600. Then you change it 2 to 5, it's increased by 30. So a total together increase 630. But if you add it to 226, you will get, this is kind of an inverse problem. You will get 856. So you have to draw the picture, okay, in order to understand this problem. You really don't need to know what is this second 3-digit number. Or maybe there are many of them, not just only 7. Maybe there are, in this particular problem, we cannot have a several. If the result, original sum is 226, you can only have 2 3-digit numbers in the summation. Okay. You cannot have more than otherwise you get more than 300. Okay. All right. So this is I'm going to ask you to do the subtraction. Subtractions, be very careful. We have to learn some terminology about what is a subtrahend and what is there's some definition on this, okay, terminology. So let me show you this, okay? If A minus B equals C, okay? And this is called subtrahend, okay? This is called difference. And what is the name of that? The first number, okay? And the first number called monument, okay? So in a subtraction, if the 1st digit in the subtrahend is changed from 8 to 1, the resulting difference is 100. What is the original difference? Ooh. All right. Okay. So write down this, right? You don't know what is A is still there, right? B is there, right? Original one is C. So now you make some change, okay? So what this change is when you increase the 1st digit from 8 to 1, the second number, right? So that means you increased how many from actually decreased, okay? Decrease the number from by 7, right? Because the units digit has changed. 1st digit is changing from 8 to, so it's minus 7 and equals 100, right? That's what you see, okay? So the result actually is, it's because it's actually you increase the original one by 7, original difference by 7. So you increase the original one by 7, you get 100. So the original one will be, the original one will be 93. Yeah. So the original difference, which is C, right? is going to be 93. Okay, so 93. So original difference 9, because the subtrahend, if you decrease the number, actually you increase the difference, because it's minus. Minus become, minus become plus. Yeah, that's right. So you have to be careful. It's different from the summation. Summation, when you increase the number or decrease the number, you actually increase the summation, okay, or decrease the summation at the same time. But for difference, if you make a change for the second number, you decrease the second number, actually you increase the difference. That's a key point. But if you gradually started to think about the problem in a abstract way, is this is how do we express, when you, yeah, how do we express? So minus becomes plus, something like that. Okay, yeah. So yeah, if you don't want to use A and B, that's okay. You think about that. Okay, I'm going to change the number, right? And some number decrease the second number, actually increase it. Decrease by the 1, and actually increase in the difference. Increase it by 1. Increase the difference by 1. Okay. For example, 20 minus 7, right, equals 13. But if you decrease the number 7, right, by 1, and then you have to increase the difference. See, right? So when this side is decreased, and this side will be increased. Okay, so because it's a subtrahend. Okay, so right, so yeah, think about this, and we can work on the next problem. Okay, in subtraction, if one's digit in the subtrahend is changed from 3 to 5, now this time increase. Okay, and the 10th digit in the subtrahend is changed from 2 to 0. The resulting difference is 400. What is the original? Yeah. All right. So this is also the second number, right? The first number we don't need to know that. The second number, right? It's here, right? The ones digit, you make some change, right? Original we don't know. That's you don't need to use ABC, right? So here, still here, no change. And this, there was some change. You subtract ones digit increased from 3 to 5. You add 2, okay? Because it increased. But the 10th digit is changed from 2 to 0. 2 to 0, you right, change from 2 to 0. So decrease by 2. Okay? Yeah. From decrease by 2, so decrease by 20. Okay. So because the 10th digit. So this is a change you make to the subtrahend. Okay. Then the final result will be, see, what you do is you combine them, right? So this is a number, right? And here's minus 18. Subtract 18 from subtrahend is actually you increase 18 to subtrahend. And then the result will be 400, right? Okay, the result will be 400. Now maybe I should use a and a B, right? A and a B and a C. So this will be A, that's a B, that's a and B. Okay, then the result will be 400, but A minus B is C, right? So the original difference will be, the original difference plus 18 is 400, right? So then it should be 400 minus 18. It's going to be 382. right? 382. Yeah, just be careful. You know, if you make a change, okay, if it changes subtrahend, decrease subtrahend by 18, then you increase the difference by 18. Okay. Yeah, if you decrease the subtrahend by 18, then increase the difference by 18. If you increase the difference by 18, then you get 400. Then the original difference will be 400 minus 18. You know, if you don't want to write down ABC, that's fine, but you have to carefully think about the signs. Okay, so if you increase, yeah. So this is this kind of training. We want to make sure, you know, the difference. Okay, as the summation, as the subtraction, the second number in subtraction. When you make a change, you have to be careful. Okay, you have to be careful. Okay. Yes. All right. So now let's look at the next problem. In a subtraction, if a 100th digit, okay, it's called a minuend, is changed from 7 to 1, okay, and the ones digit in the subtrahend is changed from 9 to 1. The resulting difference 210. What is the origin difference? Well, so now you have to change it both. Okay, you needed to change it both. So this is A, right? You write down this equals C. We don't know the original one, which is C. So we are going to modify the first number. We are going to modify the second number. Okay. Okay. So the first number is the 100 digits change from 7 to 1. From 700 to 1 means, and the first number you decreased by, from 7 to 1, decreased by 600, okay? Okay, this is our first part, okay? The second part, you look at B. Subtract the ones digit is changed from 9 to 1. So decreased by 8. And then the result will be 210. Okay, so you translate that problem. Then you have to think about what is combined result on the first side, right? So A minus 100, 600, and this will be plus because you decrease the subtrahend is actually increases the number in the difference. Okay, so you still get 210. So let's look at this, right? Minus 600, and this will be A minus B, that's the original one, and the minus 592. All right, so the original difference decreased actually 592. Then you get 210. So what is the origin difference? You have to add 592 to 210. Yeah. Yeah. So A minus B, the original difference will be 210 plus 592. Right? Yeah. It's going to be 802. Right? So we figured out the original sum. Okay, let me go through again. You know, you don't need to use use ABCs to represent some numbers. We really don't need to know their values. Okay, at the very beginning. But you have to modify. You see, A is modified to A minus 600 because the 100th digit decreased by from 7 to 1. Then for the second number, right, B, the unit, the ones digit is decreased from 9 to 1, so decreased by 8, so minus 8. But minus 8, actually, the result is added 8 to the difference. So the combined result will be the origin difference minus 592. 592. Then you get 210. So the origin difference should be 210 plus 592, okay, 802. Okay. Yeah. So we gradually we needed to, yeah, we are solving the equations right now, right? Kind of equations. Okay. some students don't want to mention A, B, C. That's okay, right? But you have to put something there to represent that's unknown number, okay? But you can do the computation in mind, okay? The first number decreased by 600, the second number actually, decreased by 8, but actually the result would be increased by 8. So, yeah. Okay. So I prefer, yeah, we should gradually learn how to use the letters to represent some numbers, okay? Now, let's have a quick review about dividend, divisor, quotient, and the remainder, okay? So if you divide a number, right, 23 and by 7, right? So then 7 is the divisor, and the 23 is called the dividend. And then 3 and the 21, you get 2, okay? So this is called remainder, okay? This is called quotient, okay? This is called dividend. This is called divisor, okay? So we also have these names. Now, how do you express them in a different way? This can be expressed in different ways. 23 is going to be, okay, it's going to be the quotient times 7 plus 2, okay? You can also express it in the following way. 23 over divided by 7, you get a quotient. The remainder is still there, so still have to divide by 2. Okay, you both sides divide by 7. Okay, 23 is over 7, and 3 times 7 over 7 is just 3, and 2 over 7 is going to be just 2 over 7. So 2 is not divisible by 7, so just stay there. But 2 is already smaller than 7, so that's called the remainder. Okay, so if you know the quotient, if you know the remainder, and yeah, then you can those are 4 numbers, the relationship. You can recover it, right? From if you know 3 of them, right? Quotient, divisor, dividend, remainder. If you know 3 of them, you can get the fourth one. You have 4 numbers involved. Okay. Now my question is, if you are given so if you divide 30 by some number, and if I write it in this form, okay, that means 30 is divided by some number p, and you get a quotient is 4, and remainder is 2, right? So what is that number? Can you solve it reversely? Okay.
What's the problem?
The problem is, how do you figure out this number? So I just say, if you know 3 of the numbers, you can get the fourth one. So suppose you know the original dividend, you know the quotient, which is 4. You know the remainder. Can you figure out the number, the divisor, right? So, right, how do you do that? The idea is very simple. If you subtract the remainder from the original number, 23 minus 2 here, should be 3 times 7. So this is divisible by 3 or by 7. That's important, okay? So the idea is the same here. 30 minus 2 should be equal to 4 times the divisor, right? So 30 minus 2 is good, what? 28, right? 28 is 4 times some number. What is that number? 7. So clearly, yeah. So 28 equals 4 times such number, and we know that number is going to be 7. Okay, that's how do we solve the problem. All right, so now let's take a look at the this number. 37 is 7 times some number plus 2. What is that number? Yes. 5. Okay, yeah, how to do that? 37 minus 2 equals 7 times that number, okay? And then 35 equals 7 times that number. Then you just divide both sides by 7. So that number is 35 divided by 7, which is going to be 5. Okay, so you get 5. So second problem, let's do the next. 292 equals 41 times some number. Yes. Okay, so it's 292 minus 5 equals 41 times that divisor. Okay, so 292 minus 5 equals 287 equals 41 times that number, and that number is going to be 287 divided by 41, right? That's why how to solve the equation. Divide by 41. And then it's going to be 7 again. Yeah, it's 7 again. All right, that's how do we solve the problem. Now let's look at this problem. Okay, you try first. Okay, in the division, if the dividend 200 is changed from change it to the 100, one gets a quotient 4 and the remainder is 8. What are the quotient and remainder in the original division? Aha. Yeah, let's see. Huh? Yeah, just divide divide and 200. Yeah, what's used to 200? Change it to. I think the idea is we have to figure it out as a divisor. Yeah. Right? If you figure the divisor, then the 200 divided by that number. So nothing's changed, only the dividend change. So the dividend, right? Right? So 100 is the new dividend, right? Okay. So 100, that's my hint. 100 is the new dividend. And when you divide by some number, the quotient is 4. And the remainder is 8, right? So if you can figure out that number, then you use that to divide 200, you can get a result. Okay, what is the divisor? 23. 23, okay. Yeah, so divisor is going to be 23 because 100 minus 8 is 4 times that divisor. It's 92 equals 4 times that divisor. That implies that is going to be 92 divided by 4 is going to be 23. So use that 23, you can divide by 200. Right? Then you can divide by 200. Okay. So yeah, let's do it. 200 divided by 23, right? So what is that number? 8.
And then the remainder is 16.
Okay, then the remainder is 16. Okay, so the answer is, yeah, the answer is you can write like this. It's it's 8 times 23 and plus 16. Okay. So this is the new quotient, the original quotient, and that is the original remainder. Okay. Okay. So got it? That's how do we do that, right? It's a two-step problem. It's not like you are given everything. You find the remainder, find the quotient. You have to use if you use use the given information to figure out the divisor, then use that same number to divide 200. Okay. All right. So let's take a look at the next problem. Right. So in a division, if the dividend 7,100 is changed to the 1,700, so one gets quotient 48 and remainder is 20. Okay, it's about same, right? What are the quotient and remainder in the original division? So somebody got 202 and 30. Okay, so how do we do that? First of all, yeah, let me move this problem down here a little bit. Yeah. First of all, 1,700, right? And use that number. You divide by, you get a quotient 48. The divisor we don't know. It's a mystery, right? Then you figured out the divisor first. So it's going to be 1,700 minus 20 equals 48 times P, right? And that number is going to be 1,680. So let's divide by 48, right? 1,680 divided by 48. So you got 35. Okay. So you got 35. So P is going to be, okay, so that's a 35. Then you use a 35 to divide the original number, right? And 710 is a 35, right? So what do you got? Like you got 2, right? 35 and then 70, then 10. Sorry, so you have to put a 0 here. And then you got 2 again, 70. So you get 30, right? So the quotient, yeah, you can write this. It's going to be 202 times 35, and the remainder is 30. Okay, so you get those two numbers. Okay, so it's the same idea. We repeat ideas. You have, it's a two-step problem. you have to figure out the divisor first before you solve the problem. Yeah, before you answer the question. Okay. Okay, so this is our first type of equations you have to solve. Right? There's only one unknown here, right? P is unknown, some number, right? And you have to find out, yeah, by solving this equation. So let's take a look at the next problem. In a division, if the dividend is 435, it's changed to 534, and then the quotient is 28. The remainder is 2. What does the quotient remain if the dividend is still 435? That's similar to the above problem. Okay, please do it. Okay, I'll give you a minute. You work on this. Hello. Yes. Okay, did you solve the problem?
Nope.
No?
Nope. Still working on it.
All right, let's start to work on the problem. Okay, so the new dividend is 500, right? 34, and we don't know the divisor, but we know if you divide by the divisor, right? The quotient is 28, so the divisor is P, right? The remainder is 2. So this is the relationship you have to write down first. So the question is, what is divisor, right? If you see something like that, how do you figure out P, right? So you have to move 2 to the left-hand side. So you get 532, right? It's going to be 28 times P. Then you have to use it. You have to divide, right? 500, right? 532 divided by 28. It's going to be 19. Yeah. So P is going to be 532 divided by 28 is 19. So you find out the divisor first. That's a two-step problem. Okay. And then you can use that number to divide 435 as the original number, right? You want to find out the quotient, the remainder of the original number, right? You have only thing you have to figure out the divisor first. Then you use, this will be 2, right? Right? and then the difference here is gonna be 5, right? 55. Then I think that would be no, still 2. Okay. So that will be 7 and 1. Okay. So quotient, this is a new quotient. So 435 is a quotient 22 times 19 and plus 17. So this is our answer. Okay. This is the quotient of the original division. This is a remainder of the original division. Okay. So anyway, the dividend minus the remainder is always divisible by the divisor. Okay. So this is the identity. So let's record the number. Okay. In more abstract way, if you divide the number by another p, then you get a quotient, blah blah blah. You get remainder, right? This is a picture, right? And then you also always have like a quotient times the divisor plus r. So this is we don't need to know this kind of general formula, but for the specific numbers we should know, right? And 534 divided by some number gives a quotient 28, remainder 2, and you should know this relationship. Otherwise, you're not able to solve the problem. Okay. So my next question for practice, okay, if a number divided by, okay, a number is divided by, okay, divided by 7, okay, and then one get a remainder. Sorry, get a quotient first. Yeah. And number greater than 5. Let me get remainder of 5. Okay. Yeah, a number greater than 5 is divided by 7, and one gets a remainder. I don't know the quotient. Okay. Yeah. Yeah. Okay. My question is, what is least possible value of the number? Yeah, so you have a number, right? Greater than 5. Otherwise, 5 is going to be the least possible value. Do you understand, right? If 5 divided by 7, of course the remainder is 5, right? And that is the smallest number, you know, you can get satisfying this requirement, okay? But now you have to find the next one, right? We still trying to find the smallest possible value of the number. There are so many numbers meet this requirement, right? For example, 68, right? If 68 divided by 7, and you get a remainder, right? 5, right? So, for example, divide by 7, right? And you get remainder. So this is a meet to the requirement, but does not mean 68 is the smallest number, right? It's greater than, it's greater than, 68 is going to be 9 times 7 plus 5. So 68 divided by, it's greater than 5, divided by 7, right? You get to remainder of 5. but that 68 is not the smallest number. So how do you find the smallest such number? 12, Mike says. Right? Yes. So the smallest, the least, possible value of the number, it should be equal to the, you just change the quotient, okay, to what? What is the smallest, right? So the answer is going to be, 1 times 7 plus 5, which is 12. Right? 12 is the least possibility of such a number, meet the requirement. Got it? So we sometimes have to solve a minimum, maximum value problems. Okay, and some, yeah. Okay. All right, so now we are going to look at more challenging problem in a division. Okay, that's a question. In a division, if the dividend changes to, okay, in a division, if the dividend is changed from 925 to 835, right? Then the quotient is decreased by 6. Okay, but the remainder remains unchanged. Okay, my question is what is a divisor? Because the divisor is not changed, right? Yeah, if we know the divisor, you can get the rest of them in the 925 divided by divisor. What is a divisor? Oh, it's pretty challenging. This is the most difficult problem at the end we're going to talk about.
You're so ahead of you. Yeah. I have no questions. Because I can't read your handwriting. I can, but I don't know how to read. Same here. I can't even read your writing. It says in
the thing, right? The dividend is changed from 925 to 200, right? 925, right? You have a quotient. You have a this is a divisor, right? Right? And then this is a remainder. Let's put the remainder, okay? Let's use the original one. Yeah. The quotient, right? And I'm going to use a D code for the divisor. Okay, that's the original one. So lots of unknowns here. And then change it to the 835. We know that the quotient is decreased by 6. The divisor is unchanged. The remainder is unchanged. Are we able to figure out the divisor?
Times D plus R. Plus times Q minus 6 times D plus R, right?
Yeah. This is the most difficult. When I just translate the sentence into mathematical symbols, but we don't need to solve such a kind of question. But is there any shortcut? I think the difference of the two dividends. should be 6 times the divisor. That's what, yeah, if you're able to figure out that. Because when you change the numbers, right?
You're going so fast that I'm
Yeah, this is the most challenging problem. Okay, we did all the rest of the problems. I think you guys already solved it. I just want to give a challenging problem at the end. Okay, and this is are you able to solve it? Yeah, think about this. Don't talk. Focus on. Yeah. So the change from here to here, the dividend, right? It's decreased, right? Right? 90, right? Decreased by 90. So decreased by 90. The decreased part is also the change in the divisor. Okay, that's all. Yeah, you don't need to put a negative sign here. It's a decrease. Yeah, if the quotient change and the value changes, right? The quotient change from original quotient to 6 less, right? Then you must have the change in the dividend. Yeah, it's 90. So that's why you get yeah, division is 15. Okay. The division is 15. So 90 divided by 90 divided by 6 is going to be 15. Okay, it's going to be 15. So once you get 15, then this is the most difficult problem. You have to involve like 2 types of identity. So, but you have to think of different way. So dividend, when you make the dividend changes, right? Use a quotient change. The change part in quotient times the divisor should be the change in the corresponding dividend. Okay, so that means the change in the quotient. Okay, the change in the dividend is going to be the change in quotient, okay, times the same divisor. Okay, yeah, change times the same divisor. Okay, if it's, everything else is remain unchanged. Okay, so this is what we see that the change in dividend. Okay, so next time if I say the divisor is changed, if a dividend is changed, increased by 75, and the quotient increased by 5. What is the divisor, right? Right. So if, for example, if the dividend is changed, okay, is increased by, sorry, yeah, it's increased by 75. Required by 75, okay, and the quotient is increased by 5. So what is the divisor? Okay. Okay, so so all you have to do is just use just write down 75 equals 5 times the divisor. Okay. Yeah. So well, yeah, let's stop here.